All right, and now it is time to talk about our next category of rocks, and that is sedimentary. So, sedimentary, the origin of these rocks is right in the title, and that is sediment. So, where do we find sediment? Well, we often find sediment at the bottom of rivers, or sediment could be carried by wind. And water and wind are two of the major ways that we create sedimentary rocks, especially water. So, as I mentioned, we have, our three different rock families, and that's going to be our igneous, which is the ones that are melted and born from fire. We have our metamorphic, which are going to be those that have been subjected to intense pressure, intense temperatures. And we have sedimentary. The sedimentary ones are kind of created by, um, they're kind of. They're kind of the garbage pail family of rocks, right? They've been eroded and cemented and carried by water and smushed together over millions and millions of years. And so they're a collection of lots of different types of materials. What's great about that is sedimentary rocks tell a story, okay? And to explain that, I'm going to go off of our very first one here. So, just real quick, um, sedimentary rocks come in three different categories. We're going to be looking at mostly at our clastic types of rocks. Clastic rocks are ones that are made from breaking things apart. Chemical ones are made by chemical chemical reactions, and biological are ones that used to be alive. I don't have any samples here of chemical or biological, but I can tell you about them later. Boop. Okay. So, what's really great about sedimentary rocks is they are broken up pieces from larger rocks, right? Especially again, that clastic, right? Clastic are going to be the pieces that are broken off from larger rocks. The majority of sedimentary rocks are clastic. So if I have a rock that was, say, an igneous rock, maybe it's a piece of granite, and then over time water has washed away at it, and now I have all these teeny tiny little pieces, little baby granite, right? That's going to get washed and then deposited somewhere, and over time, all those layers are going to get smushed together to create a new rock. Well, all those layers, right? And often on many, not all, on many sedimentary rocks, you can actually see the different layers. Let's see if I can zoom in and show you these stripes here. We call these stripes strata. Let's see if I can get my camera to cooperate. We call these stripes strata. This here is a shale. Okay, it's not a very fancy rock, right? Although we do have oil shale, which you can extract oil from. So this shale, which is going to be a collection of clay and bits of mud and silt that again you're going to find around water. All right, so water is going to be the major carrier of sedimentary rocks. Wind and glaciers can do some too, but rivers are your main culprit. Okay, but you can kind of see a little bit here. Oops. Oh, that's not blood, it's marker. I'm not dying, don't worry. The hazards of being a science teacher. All right, that's just marker. I scared myself. Okay, so these different layers here are going to tell a story. We call them strata. It's kind of like if you ever have made lasagna or casserole, right? Strata is another Italian dish that's going to be layers of different things, all right? So if I think of this as my lasagna rock, right? So maybe this little layer right here is going to be my pasta, and maybe here is my um, bologna sauce or bolognese sauce, right? And there's my spinach and there's my ricotta cheese, whatever you put into your lasagna, right? You can kind of see some color difference here. Well, each of those layers comes from a different time period, all right? So if I know that I find my shale like this, and that this is the top, so this is going to be the year 2019 or whatever, and then going down, maybe this is the year 1500, maybe this is the year 1000, right? And I can look at the different materials I find here. Maybe I found some really cool fossils. Maybe I found some very unusual pollen fragments. I can go back in time and tell a story of what was there when this rock was first being formed. Okay, so shale, a very classic example of sedimentary rock. Okay, you can see it's not very flashy, right? It doesn't have chunks the way that any of our um, intrusive igneous rocks had. The big feature of shale is going to be these different strata, and you can kind of see here. These different strata are going to be those layers that are very, very useful, especially for archaeologists, because when we date samples, we are dating the rock around them, is helping us do that. Okay, so that's shale. Another very classic example of a clastic sedimentary rock is going to be good old fashioned sandstone. All right. Again, not a very flashy rock, right? Sedimentary rocks are usually not very glamorous, but they're very functional. And so you know it's a sedimentary rock because as I rub my fingers on it, I'm actually getting pieces of sand off on it. Okay. So little pieces of sand come off on it. And really, this is just a whole bunch of sand has been smashed together. Ta-da! That's really all there is to it for sandstone. Okay. So again, this is going to be that cementing process in sedimentary rocks where I had a whole bunch of silica, and this kind of orangey color means there could be iron oxides, right? That kind of rusty color. I've seen some sandstones that have been very orangey in color. Um, you might have some calcite in there. And so you had sand that was carved by wind, carried by wind, right? And then all gets smushed together over time. Okay, so all these little sand pieces over time were smushed together to create this sandstone. All right, so sandstone is literally just stone made of sand. That is all there is to it. Now, because we have this tendency to smash things together, sometimes you get really messy sedimentary rocks, right? This is what I like to think of as the granola rock. Please don't eat rocks, right? Please don't eat rocks, but this is a great example of what we call a conglomerate rock. And you're like, Rachel, did you just find a piece of concrete in the backyard? No, I didn't, I promise. Right? But concrete would be a great example of a conglomerate or classic sedimentary rock. All right. If you look at this lovely guy here, it really is just a collection of a whole bunch of different little tiny pebbles. That's all there is to it. It's not very attractive, right? It really does look like it could just be a piece of concrete. I hope I didn't get ripped off by the rock company, right? But you see all these little pebbles and rocks are kind of all held together by this glue that's slowly coming off of on my board here, right? And so again that cementing process that is so crucial to sedimentary rocks. Again, sedimentary rocks don't have to be glamorous, but they tell a story. Where did all these other pebbles come from? Where did all these other pieces come from? And how did they get carried to where they are today? So another similar to a conglomerate, which I don't have, so conglomerates are classic, right? They're pieces of things brought together. You also, it's going to be where you have a biological sample. And so there's a type of rock called coquina, which is going to be a bunch of shells smushed together. And again, it looks like granola made from seashells. And so if I find a piece of coquina rock in the middle of a desert, what does that tell me about what this landscape used to be? Well, if I have a piece of rock made from seashells, there probably was an ocean nearby, or at least a body of water that supported, aquatic life. And so again, when they all kind of cluster together and they're cemented together by different materials, that compaction, they tell us a lot about what landscapes used to be there. So that would be one example of biological. Another one would be if you were ever a naughty child and Santa brought you coal. Coal is a great example of a biological sedimentary rock. Coal used to be ferns, actually. So we have a lot of coal deposits in eastern United States because the eastern United States used to have a lot of lush rainforest like ferns long time ago. Right? So we look at coal and we consider it a fossil fuel because it is a fossilized plant material, right? So it is biological in nature. Nothing really broke off. These organisms died, and then over time, their carbon structure was cemented into coal. All right. Um, Another interesting one, and I'm going to combine these two together because they're related. And these are going to be two different types of limestone. So limestone, if you've ever done any work with rock, any sculptures or carving, limestone is kind of like one of the celebrities of the carving world. Let me move that out of the way. Maybe that'll help it focus better. There we go. Um, so limestone is really kind of one of the celebrities of the rock world. And if you are into art history or architecture, you may have seen many beautiful buildings, especially in Western Europe, made from limestone. Popular for use in cemeteries, for tombstones as well. So limestone is made of calcium carbonate. All right, so calcium carbonate. The interesting thing about calcium carbonate, it's kind of similar to Tums, like when you have acid indigestion. Again, don't eat rocks; they will not help your acid indigestion. But it's kind of the same idea behind it. It's calcium carbonate. Another thing that calcium carbonate is also found in is the shells of sea animals. So your crustaceans, your crabs, your shrimp, your any all those things that have clams and seashells, right? So the thing about calcium carbonate is it's very sensitive to carbonic acid. And the idea behind carbonic acid, if you've ever had Alka-Seltzer and you've dropped it in a piece of water, a glass of water, what does it do? It bubbles, right? It bubbles. It's creating carbonic acid. If you have a carbonated beverage, think about the word carbonation. It has carbon in it. So if you have a soda water or just a plain old soda, that carbonation is carbonic acid. And carbonic acid can play a big part in breaking apart my calcium carbonate. Okay. And so we kind of see this in tufa. Tufa is a very specific type of limestone. Again, the chemical structure is the same, they're both calcium carbonates. The difference is this is going to be coming from heated water. Okay. So this is going to be a precipitate from from heated water, okay? But still a type of limestone. So tufa versus limestone. Okay? What's important about limestone is the way it reacts to that carbonic acid to water in general. So what can happen with these guys, and you could probably consider this a chemical type of sedimentary rock. I don't, but if you want to, I'll give you credit for that because a large part of how these are created are these play a big part in caves. So if I have water running through limestone, it's going to carve away at that limestone. Okay, so limestone gets carved away very easily by water. So now I have water that's containing little tiny dissolved bits of calcium carbonate. And that's the key behind chemical sedimentary rocks is they are dissolved into water and then later deposited elsewhere. So what happens with my limestone is dissolved and then within my cave system, it gets deposited into your stalactites and stalagmites, right? So those are rocks that have been formed because my chemical reaction, my calcium carbonate, has then solidified back out of my water. Okay, so again, most of the world's caves are found on limestone. But this also can be a downside too. So one thing that happens with calcium carbonate is if it's exposed to acids like carbonic acids, it melts. So what's happening with a lot of the older architecture in Europe, or even in the eastern part of the United States, where we have some older buildings and older cemeteries with limestone tombstones, is they're being melted away. Like if you see pictures of those gargoyles, that their faces are just like obliterated, right? Because they're being melted by acid rain. Acid rain contains a lot of carbonic acid in it because it absorbed it from industry and pollution from too much carbon dioxide being released in terms of factories. We also see this impacting a lot of our aquatic friends. So the shells of seashells and clams and crabs are getting thinner because that chemical reaction of so much carbon dioxide being absorbed by my ocean turns it into carbonic acid, which then melts away at their calcium carbonate shells. Okay. One more type of chemical sedimentary rock that you might not realize is a rock. You do sometimes eat rocks, and that is salt. So salt is sodium chloride, right? It's a mineral, but it's a type of mineral that makes a rock. And so when you think of rock salt, it literally is a rock. It really is. So next time you put some salt on your baked potato or on your eggs, you're like, wow, I'm eating rocks. But salt would be a great example of a chemical sedimentary rock because they do precipitate back out. If you dissolve salt into water and then let the water evaporate, then you get solid salt at the bottom of your glass. That's all we have for our different types of sedimentary rocks. As you can see, they are vastly different. Most of the ones we have here today are clastic. In fact, I personally would classify all of these as clastic. If you want to talk about limestone being chemical, you certainly could. We don't have any biological specimens here. We did talk about how coquina and coal are both examples of those. But a great way of telling the history of a location by tracing the different materials you find, because all of these materials were brought from other locations. So sedimentary rocks are kind of the storytelling rocks. That's all I have for you. Thank you.